Hi, my name is Sam Galen, and today I'm going to be talking about black holes. Einstein's theory of general relativity accelerated our understanding of black holes in the earliest 20th century. Carl Schwarzschild, a German physicist, first predicted their existence in 1916 using Einstein's theory of relativity. In 1965, Roger Penrose used the theory of general relativity to demonstrate how a singularity could form. The term black hole was later coined in 1967 by American astronomer John Wheeler. After decades of black holes being known as only theoretical objects, Cygnus X1, the first physical black hole ever discovered, was spotted in 1971. Research into black holes continues to make news, with the first image of a black hole in 2019 and the Nobel Prize recently being awarded to scientists who study black holes. NASA defines a black hole as a place in space where gravity pulls so much even light cannot escape. The gravity is so strong because matter has been squeezed into a tiny space. This can happen when a star is dying. Because no light from a black hole can get out, they are invisible to the human eye. The size of a black hole is undetermined. Scientists have theorized 4 different types of black holes: stellar, supermassive, intermediate, and miniature. Stellar and supermassive are the most common. A stellar black hole has a mass of about 20 times more than the mass of our Sun, and is formed when a massive star dies and collapses. Supermassive black holes are the largest at millions or even billions times the size of our Sun. Scientists believe that every large galaxy contains a supermassive black hole at its center. A supermassive black hole called Sagittarius A is at the center of a Milky Way galaxy. It has a mass of about 4 million suns. Albert Einstein's theory of general relativity explains the law of gravitation and its relation to other forces of nature. It predicts that a sufficiently compact mass can deform space-time to form a black hole. The stronger the gravity, the slower the pace of time. This image depicts space-time distortion, as gravity changes the path of matter, including light. Although light follows the shortest path through space-time, it is an extremely large concentration of matter that distorts space-time, and the shortest, most direct paths are no longer straight, but curves. A stellar black hole forms when a massive star collapses upon itself. This collapse can also cause a supernova, or an exploding star, that blasts a part of the star into space. The size of a black hole is related to the size and mass of the galaxy in which it is located. Stars with a core greater than 3 times the mass of our Sun will collapse forever. A black hole cannot be seen due to the extraordinarily strong gravitational pull that attracts all the light around it into the center of the black hole. The scientists can see how strong gravity affects the stars around it and gas around it around the black hole. Scientists can study stars to find out if they are orbiting a black hole. As the black hole and a star collide, a source of high-energy light is made that the human eye cannot see. Scientists use satellites and telescopes to detect this high-energy light. Scientists can also detect black holes by observing their effect on nearby matter. This includes accretion disks and quasars. Accretion disks are particles of dust and gas that form when falling toward a black hole. Quasars are jets of particles that blast out of supermassive black holes. This figure illustrates an accretion disk surrounding a black hole with a quasar in the middle. There are 2 basic parts to a black hole: a singularity and the event horizon. The event horizon is a point of no return around the rim of a black hole. It is not a physical surface, but a sphere surrounding the black hole that marks where the escape velocity is equal to the speed of light. It is determined by the Schwarzschild radius, which is calculated as 2 times the gravitational constant, multiplied by the object mass, and divided by the speed of light squared. The larger the mass, the wider the event horizon. A singularity is a one-dimensional point in the center of a black hole, which contains a huge mass in an infinitely small space, where density, as well as gravity, become limitless, and space-time curves infinitely, and where the laws of physics, as we know them, cease to operate. Time slows to the point where it appears to stop. The figure on the right illustrates the singularity in the event horizon. In 2013, astronomers observed a supermassive black hole at the center of a galaxy called NGC 1097. Their research indicated that the black hole was composed of hydrogen cyanide. They theorized that this was caused by high-temperature heating of the environment surrounding the black hole. It is a myth that Earth could be swallowed by a black hole. According to NASA, black holes do not go around space, eating stars, moons, and planets. Earth will not fall into a black hole because no black hole is close enough to the solar system. Even if the sun became a black hole, the Earth would not fall into it. The black hole would have to have the same gravity as the sun. Earth and other planets would orbit the black hole as they orbit the sun now. The idea that the sun would turn into a black hole in the next few billion years or so is false, because the sun is not massive enough to become a black hole. Instead, the sun would cast off its outer layers, and its core would form a white dwarf, a dense ball of carbon and oxygen that no longer produces nuclear energy, but that shines because it is very hot. On April 10th, 2019, the first image of a black hole was officially unveiled. It was captured by the Event Horizon Telescope and rendered by a complex algorithm. The Event Horizon Telescope is a project consisting of 6 different radio telescopes scattered around the Earth that work together to gather more than a petabyte of data. It took scientists 2 years to assemble that data and eventually created the image, which you can see on the top right of the slide. More than 50 million light years away, in the heart of a giant elliptical galaxy called Messier 87, a supermassive black hole contains the same mass of about 6.5 billion suns. The picture in the bottom is of Dr. Katie Bauman with all the code it took to render the image. Just a few weeks ago, the Nobel Prize in Physics was awarded to 3 scientists who have made great headway in understanding black holes after decades of study. Roger Penrose, who in 1965 used the theory of general relativity to model the concept of collapsed matter, forming a singularity, who shared the prize with Reinhard Genzel and Andrea Ghez. Genzel and Ghez led teams of astronomers beginning in the 1990s, developing methods to see through clouds of interstellar gas and dust to find evidence of Sagittarius A, a supermassive black hole in the center of the Milky Way. Their research continues today. An unknown number of black holes are scattered across the universe, constantly warping both space and time, and inspiring scientists to learn more about them. We still have much to discover about black holes, and to this day, extensive research is being done to further scientific understanding. Thank you.